For nearly 40 years, SDT Ultrasound Solutions has been dedicated to advancing lubrication practices. From hands-on research to breakthroughs based on data gathered from countless field measurements, our journey has been marked by the creation of tools, each more innovative than the last. Thanks to the development of our LUBrain algorithm, this acquired experience can now be incorporated into a game-changing solution, the LUBExpert ON-GUARD, our automatic bearing lubrication system. It is often said that 80% of bearing failures are due to inadequate lubrication. When a bearing is suffering from increased friction, ultrasound technology allows us to hear these failures. The common sense sensors pick up these ultrasound signals and send them to the LUBExpert ON-GUARD. The data is then analyzed and processed by the LUBrain algorithm, which calculates the appropriate quantity of grease to inject into the bearing. Finally, this data is fed back to the automatic lubricator installed on the machine, instructing it exactly how much grease to inject and when. The bearing, automatically lubricated, can therefore continue to operate at optimum efficiency. Meanwhile, the operator is able to view the data collected on the web interface and determine the strategy to follow.
Automatic lubrication. It's something that's been around for a long, long time. In fact, if you want to trace it back to 1872, the first patent for automatic lubrication was awarded to Elijah McCoy for his work on creating lubrication systems in engines. Previously, engines would have to be stopped before they could be lubricated and then started up again. His invention saved precious time and resources and helped spur on the first industrial revolution. Fast forward to a few decades ago, and we have products like this automatic lubricator that you see here, which we now can position in industry to automatically lubricate our bearings. But these lubricators weren't invented for the sake of the bearing. They were invented for the sake of the people who were responsible for maintaining those bearings. By putting automatic lubricators into the field, it saved on man hours and it saved on accessibility and increased safety that allowed these bearings to be lubricated without having to send soldiers into the field with grease guns. That's all fine and well, but it didn't help us transition from that time-based regimen to the evidence-based, condition-based regimen that we really need to grease bearings right. And that's why I'm super excited today to be before you with my colleague, Robert Dent, to talk about a new innovation in controlling these automatic lubricators. My name's Alan Reenstra. I'm with SDT. We are the world's favorite ultrasound company, and we're here today to talk to you about LUBExpert ON-GUARD, the latest solution in industry for automatically controlling the injection of grease based on evidence and the real needs of the grease, not on the convenience of the people that have to go out and grease them. So I'm going to pass it over to my colleague, Rod Bent, so he can take us through the LUBExpert ON-GUARD.
Okay, thanks, Alan. Great to be here. So this is a really great, innovative product. I've been involved with the development and testing of this product for about the last 12 months. So we have been rigorously testing this, beta testing this in the field with a number of our close partners, our close customers. And we are at the point of product launch, which is super exciting. So what is the LUBExpert ON-GUARD? So it is a 1 to 8 channel online monitoring system designed for smart lubrication assisted by ultrasound. So we have basically a PLC which has SDT's LUBrain algorithm, so a very sophisticated piece of software, very sophisticated algorithm within the PLC, which is being fed data from our ultrasound sensors and then is able to make intelligent decisions based on how it's configured to initiate the lubrication through the impulse controlled auto luber over here. One of the nice things about the LUBExpert ON-GUARD, it's handled through a standard web browser. So we can view the information, we can see real-time what's going on, we can see historical data through a standard web browser. So we don't need to worry about installing a bunch of client software. There's no back-end database required for installation. So a little bit easier from an IT perspective to get things up and running. And it really sits well with our mobility system, which is designed to be put on an asset for maybe a short period of time, and then move to a different asset. There's no licenses required, and all the data that's collected are displayed via trends and dashboards, and it's hosted directly within the PLC itself. We have two different solutions. So the first one being permanent. So the idea here is that we are going to have this installed in a rugged industrial type enclosure out in the field. The sensors and the single point lubricators wired back to the PLC, and it's designed to sit out there and be connected on that specific asset permanently. Second option is our mobility system. So the PLC has been installed in a rugged IP67 case. Everything's wired out to analog inputs and outputs on the side of the case for ease of connectivity. And everything that you need for this 4-channel system is included within the kit itself. So it comes with 4 of the precise metering single point lubricators, 4 of our CON1 sense sensors. There's a gateway in there as well, so we can communicate a number of different ways, whether it's directly onto the LAN, over Wi-Fi, even over mobile network using SIM cards. So it gives us a lot of flexibility for putting a device out into the field and accessing the data very, very easily.
So you said the mobility is a 4-channel?
Yeah, mobility is a smaller unit, 4-channel. The permanent can actually support up to 8 channels. But for most of the time when you're looking at a mobility system, you're probably going to deploy it on a single asset. And most of those assets are going to have, a motor or a driver, and then whatever's being driven. In a lot of cases, it's going to be ball bearings for the most part.
So one mobility can cover a complete machine system.
Complete asset. That's the idea. Absolutely. So I'll go into a little more detail. So the hardware itself, 8 analog inputs. So here we have the ability to bring in the data from our ultrasound CON1 sense sensors. Great thing about these sensors, no configuration required. Plug and play, nice and easy. We also have 8 configurable relay outputs on the PLC, and that's what we're using to communicate to the autolubers. One of the great features about this as well is we're providing power to the autolubers from the PLC, so we don't need to worry about batteries going dead in the middle of the day or halfway through the night, because we're giving continuous power through our connection from the PLC. There's 2 additional relay outputs. We can use these for communication to other business systems, the triggering of alarms, got a big klaxon going off if something goes wrong, but some options there for how you want to get additional data out. It is continuously monitoring ultrasound and temperature. So the sensor, the ultrasound sensor, will actually record the temperature from the bearing housing as well, so we can see how that signal evolves as well as the ultrasound. Super important with lubrication. We want to capture multiple pieces of information. It's going to make us way better at what we do. Multiple different strategies for lubricating, and we'll talk about this in a few more minutes, and how that can be configured. Obviously, the PLC itself and that web server, which is embedded right in it for ease of connectivity. And we can also move data easily via Modbus TCP, which is a pretty standard industrial communications protocol. Software, so everything's embedded. When we connect into the system via a standard web browser, it's going to bring us right to the dashboard. So we're going to see right on the dashboard here the channels that we have configured. We can very easily see which machine it's on, which point on the machine. So here, in my demo system here, I've got pump system number 1 and number 2, and I can see I've got my pump 1 motor outboard bearing, pump 1 motor inboard bearing, etc., etc. So very easy for me to identify what's going on. And from here, I can directly click on one of these to jump into the specifics of that channel, look at it real time, look at its history. This dashboard also, though, gives me a 30,000-foot view of what's actually going on real time. So green is good, amber or yellow is some kind of warning, and red is going to tell us that there has been some kind of interaction which has generated an alert that we need to actually dive in and kind of take a look.
I love that this dashboard lets you just jump into 8 different assets. They could be anywhere in your plant, but you don't need to physically get up and go see them.
Absolutely. So I can jump into that specific bearing and look at that specific lubricator and see what has occurred over, the duration of the time it's been there historically. So
Cool.
So what I'm going to do now is actually jump onto a live system and look at how things are configured. I was going to make this a little bit easier for demonstration purposes.
Oh, so this really is a live demo.
Yes, this really is live. Yeah. So you know what they say about doing things live. Don't work with children and animals. Hopefully, we don't have any in the office today. So the on-guard system itself. So here you can see as I hover over each of the channels, I get a little change in my cursor from my pointer to my little finger pointer. So that gives me an indication that I can click on this and jump right into the information about that specific bearing that this ultrasound sensor is connected to. So right here on the screen, I have lots of great information. So here's my trending right here on the screen, and the different trend information or the parameters that I can trend are listed here, from my RMS readings, my alarm threshold, safe alarm, sensor temperature, amount of total added quantity of grease. And I just by a simple clicking of these with my left mouse, I can turn these on and off so that they appear or don't appear in my live trend. Now, along the bottom, I have my real-time data that's coming in continuously. So here's my RMS reading right now. We're at 36 decibels, microvolts.
So that RMS is giving me an indication of what?
So this is giving me an indication of the acoustic emissions being generated by the friction in this bearing. So as those acoustic emissions increase, they're going to go up, and when we reduce friction, hopefully they're going to go down.
So that's a live indication of the severity of the friction going on in a specific asset.
Absolutely. And with some baselining and some trending, I can generate an alarm threshold for that reading. So it gives me a way to really identify the optimum time for me to grease this bearing. So here's my RMS reading, my alarm threshold. I can also set a safe alarm. What's nice about this is I can set a low alarm set point. So if the RMS drops below that, maybe the machine shuts down. We don't want that to have any bearing on a lubrication event. So we can set that safe alarm to say when it goes below this, just go into kind of pause mode or waiting mode and don't perform any lubrication. We also get an indication on here of the last time that there was a lubrication, what was my initial reading, so what was the RMS reading before we greased, and then what was the final reading after we'd finished greasing. So that's going to be right there on the screen. And for that last event, how much actual grease was deployed through that event. So very quick and easy information that's seen on the screen and is right there for me to see. Now, down the right-hand side, I have an indicator of some other information. So what's the cartridge status? So obviously, one of the questions we get asked is, how are we going to know if the auto lubricator is getting low on grease?
Well, that's the single biggest criticism of auto lubricators is that people install them, but then they don't go out and check them.
Right. It's something that could be easily forgotten if you don't already have a work order or a PM in place to go and check those on a regular basis. Great thing about this system, it's automated. We are actually keeping track of the amount of grease that's being put into the bearing. Therefore, we're able easily to keep track of how much grease is left in the lubrication cup or the canister there.
That's a bonus.
Yeah, definitely. As I mentioned earlier, we are providing power through the PLC. So we don't need to worry about the batteries going dead and the auto lubricant not functioning anymore. So again, something we can take away from this is we don't need to really be concerned that this is going to fail for some unknown reason like dead batteries, lack of grease.
Or lack of attention from maintenance.
or lack of attention from a human. Absolutely.
Yeah.
We get our current operating status. So here, currently, we're waiting. So what this is telling me is that it's basically listening. It is sampling the data and it's waiting to act. So it truly is on guard. Depending on how we've defined it to trigger, it's going to sit there and just sample, listen, monitor. And when that triggering event occurs, it's going to jump into action.
This isn't a system to control a lubricator. This is an online condition monitoring system.
Absolutely.
Okay.
So if I jump into my configuration here, get a little in depth, we can see that although quite complex, there is some simplicity here. So we have really three pieces of information or three configuration choices we need to make. The cartridge configuration. How much grease is in my lubrication cup or my little canister there?
Yep.
We're going to put in, what is the full quantity value? It's going to automatically calculate the remaining quantity based on how frequently it lubricates and how much grease is deployed. We're going to specify the discharge amount. So in conjunction with the setting on the auto luber itself, we're going to specify every time that we do trigger an injection, how much grease from there is going to be put out. And then we're also going to put in a discharge duration, and we can modify this to determine how long we want to wait between discharges. So we give it some grease. In this case, we're going to wait at least 30 seconds for it to finish the process before we would even consider putting any more grease into the bearing. Now, the replenishment side of things, we've got a couple of different options here. We can do a one-shot only. We can do a specific quantity during a triggering event, or we can use the LUBrain algorithm. And this is where it gets really cool. The LUBrain algorithm is what is used to monitor that friction as grease is being deployed into the bearing. And it's going to determine whether it adds more grease, it stops, or through the process of it adding grease, when it gets to the point where the friction has kind of bottomed out and starts to tip up again, it's going to stop the process there, and it's going to record all of that information. So how much grease is put in, how many triggering events or how many grease deployments were made during that actual event.
So the exact same intuitive intelligence that's built into our portable LUBExpert, which thousands of people are already using in the field to grease bearings right, essentially has been transformed into or transferred over into this condition monitoring system.
100%. So now, instead of having someone out in the field going through that process, which is a phenomenal process, we've now automated it. So, you're taking away the necessity for someone to go out into the field and do it manually. Now it's going to do it based on condition. So when the friction changes, the system can then jump into action.
Based on evidence.
Based on evidence,
Love
yes. We also have some triggering options here. So we can determine we want to do it on alarm. We want to do it based on operational time, so the amount of hours, or we can specify to do it in free mode. Maybe we don't want to let the system autonomously do this by itself at the beginning. Maybe we want to look at this, monitor how it is over time, and using free mode, we can click on a button here and say, okay, give it some grease now, and let's see what happens.
So basically, I could be sitting at dinner with my wife and she thinks I'm scrolling reels, when in actuality, I'm greasing bearings back at the plant.
Absolutely. Yep.
Love it.
So we'll come back to our overview screen for channel 1 here. You also see that I have another option here, which is asset information. So this is where I can put in the specific information about that particular asset, where it's located, what its name is, which particular bearing is this lubrication point. I can add in here as well the actual grease that I'm using. Maybe it's a Mobile XLP or whatever it happens to be. So as a reminder as to the specific grease that needs to be used for this bearing, that can be put in here along with any additional information I think might be important.
Yeah, be careful if you do that at dinner that you don't type in olive oil.
Yeah, absolutely. Or maybe in a food-based environment. You never know. Now, one of the other great things from here as well is I can actually historically look at what's been going on with the system. So by using the control button, I can click on a number of these different parameters down here, and I can identify what I'd like to see historically. So I can jump into our graph mode here. I can specify a time frame, so say 1 week, and look at what has happened to the system or to this bearing and the lubrication for this particular bearing over time. So in this particular case, we can see nothing has really gone on. We've got a very, very stable RMS dB microvolt reading here. And the reason why is because we're on a test system. So why don't we jump across to a real system and see what history on a real system would look like? So
take me to the battlefield.
Absolutely. So here over the last 2 or 3 weeks, this is a live system installed out in the field right now. Here is my dB RMS reading. Here we have an alarm set at 39.
That's the top line. The top line.
The red one, top line, absolutely. So you can see my trend here of my dB RMS, nice and smooth, pretty consistent. But then when it does go up above alarm, this is when the system jumps into action. Now we can see from this little green one here that the lubricator has been triggered, and we can see how much grease was actually deployed through that injection process. So we had 5 shots of grease in this case, and through that process, it brought the dB values back down again. And then as it spikes or goes into alarm again, it's going to do the same thing.
What was the time frame in between those injections?
Well, I can zoom in here. And I can see here, so we started at 5:10, and the second injection happened at about 5:15, so about 5 minutes between injections, based on how we set it up in the system. And I seem to remember when I was looking in there, we had actually identified that it would be a 5-minute pause between injections. And this is configurable again because it allows us to determine how much wait time from when we put 1 shot of grease into the next. So depending on the speed of the machine, the size of the bearing, we can tailor the configuration for each bearing, each lubricator, to react or act in the way that is necessary for that specific bearing.
One of the biggest criticisms that I get from the field when we're trying to promote evidence-based precision lubrication of motor bearings is the time that it takes. In a time-based regimen, I've got a work order that says, go to the machine, inject 30 grams of grease, and go to the next machine and inject 20 grams of grease. Put your check mark in the box, say your job's done. You don't have any idea whether or not the job improved the condition of the bearing or made things worse. But the argument is always, to do it this way, it's going to take me 10 times longer to do my job.
Right.
My counter argument is well, if you want precision, then you need to have that time. But now we don't need that time because LUBExpert can do it. LUBExpert ON-GUARD can do it for us. You can see we don't have to sit there in the field and wait for 5 minutes between injections to see what happened.
System's going to do it for us. It's continuously on guard. So, one of the other great things about this as well is, obviously determine based on the asset and the size of the bearing and the speed, it might take hours before the grease actually gets into the raceway and has an effect on the friction and changes it whether it's up or down. So being able to set that specific time frame and not worry about, hey, I got to remember to go back to that bearing in 4 hours, or I got to check that bearing again tomorrow. The system's right there. It's going to make sure that what happens and it's done when it needs to happen. So zoom out from here again, and I can go back to my history. And again, we can determine what we want to look at, how far back we want to go. We can look at specific events. We can, zoom in, zoom out, all of that good information. We have lots of other information in the system, but I think this is a pretty good sneak peek as to what we can do with this system. Obviously, as with any technology and any program, you're probably not going to deploy this on every single bearing in your facility.
No.
There's going to be some criteria that's going to need to be met, whether it's based on accessibility, criticality, safety. These are those ideal assets where we're going to deploy something like this.
To me, accessibility and safety go hand in hand. I mean, it's the inaccessibility of so many of the bearings we see now being guarded out for safety reasons that we can't get to them and lubricate. In fact, we even see some bearings being lubricated while the machine's not running because it's a safety issue. And that's one of the most dangerous things you can do, because you haven't got that kinetic energy to push the grease, to inertiate the grease to where it needs to be. So this is huge that way. The second aspect, criticality. I don't know if I want to put criticality ahead of safety in terms of priority, but certainly this is going to be installed on a critical assets first.
I would definitely think so, for sure. But yeah, and to your point about greasing bearings when there's no inertia, we're not able to monitor the condition. So we don't get that feedback from the bearing as to whether we're doing something good or bad.
Yeah.
We're hoping we're doing something good by putting grease into a bearing, but with a system like this, we're going to get that results orientated feedback so that we know, yes, we need to continue putting grease in, or no, we don't at that point.
That's the biggest thing missing in a manual, unaccountable lubrication regimen today, is that there's no. It's the only job that I know of in maintenance where you put a check mark in the box and you have no idea if you improved or made things worse.
Yeah, it's kind of like having a gas tank where the needle in the car doesn't work anymore. You're gonna go to the gas station and you're gonna probably put some gas in, and the only way you know if you've done a perfect job is when it starts spilling out the top. But how do you know from then on, when do you need to go back to the gas station?
Right. Well, that's bad enough as it is, but if you put this in terms of, we're medicating our bearing,
Right.
we're not over medicating. We're not going to over medicate our children if they have a fever.
Right.
This is literally an intravenous drip for a bearing.
Yeah, I mean, one of the constant problems, or one of the problems that we have with lubricating bearings, is we tend to go through this feast or famine type events where we go and we give a bunch of grease to the bearing, and in a lot of cases we over lubricate the bearing.
But that's because we're lubricating it for our own convenience,
Right.
not the necessity of the machine.
Then over time, that grease, it starts to get worn in. It will decay and die over time, or at least the additives in the grease will. And then we're probably going to get to a point where we're reaching starvation, and it's this up and down feast or famine type thing that we can really avoid with a system like this, where we can really precisely monitor this and add a small amount of grease when it needs it.
How many lube techs or how many lubrication programs do you know about where the work order says go out and grease the bearing because it actually needs it? We have evidence that it needs it, so go out and grease the bearing, then come back a day or 2 or 3 days later and see if it needs more grease.
Yeah, not very many that I've come across.
No. So in this situation, we have instant feedback, but we also have feedback 1, 2, or 3 days later to see whether or not there's a condition that's existing in that bearing that's forcing that, making that fresh grease get used up sooner than we think it is.
Right. Now, when we add, the temperature reading in with this as well, we've now got another parameter that we can use to identify that what we're doing is beneficial.
Is temperature a leading or a lagging indicator of lubrication film condition?
Lagging.
How so?
Well, as we increase friction or increase the amount of grease that we're putting into the bearing, the temperature is going to increase. So as friction goes down to the point where there's no film in there, no grease in there, temperature is going to increase as well. So it's something that is going to give us good information. But if we're only waiting to respond based on temperature, then we're not really reacting when we need to. We're waiting for that lagging indicator to tell us what we need to do.
That makes a ton of sense. It's a lagging indicator of bearing condition and lubrication condition. It could be a leading indicator that you've overgreased.
Could be, but something that through the system you're going to see as the grease goes in, how does the temperature react as well as the friction? So
This is truly an innovation. I mean, there are systems on the market today that are piloting automatic lubricators based on ultrasound, based on condition. Where does this LUBExpert On-GUARD step ahead of those systems?
I mean, it's number one. It's the best. Go SDT.
I agree, but I have to think it's all to do with that LUBrain, that patented LUBrain algorithm.
Yeah, all joking aside, I mean, what we've done here is we have, over years of experience, years of greasing bearings, years of developing the algorithm, we have put all of that intelligence of countless hours of experience into the system so that, we can do a really good job of precisely lubricating bearings.
That's exciting. Listen, thanks for explaining this. Thanks for revealing this this latest innovation from SDT to the world. I'm sure there's going to be a lot of questions, more than what we're covering in this short little segment. There's going to be a link at the end of this video to a form where people can click and go to the landing page and request. They can ask questions. They can request to have an online product demonstration or even a visit into the plant. Anything else to say about this as we close off this first reveal?
No, I don't think so. I mean, we're all very excited about this product, and we can't wait to start working with you.
Awesome. Thank you so much, Robert Dent, and thank you everybody for tuning in to listen to our new product, LUBExpert On-GUARD from SDT, the world's favorite ultrasound company. So long.
So long.